Hi, welcome to this week's CS4HS Hangout on Air. This week we have Reena Lee, who is going to be talking to us about voice recognition in search. So, Reena, I'll let you introduce yourself.
Sure, thanks, Erin. So my name is Reena Lee, and I work at the Google Mountain View office. And I'm currently working on our speech recognition team, which is used in many Google properties, including voice search, but also used by Google Glass, Google Translate, and any properties where you see a microphone on a Google application. It links back to our speech recognition. So today I'm going to give you a little bit of insight about speech recognition and our different applications that leverage it and some of the innovations and areas that we're working in. I'm going to go ahead and switch over to some slides.
And while Reena is setting up, I'll remind our viewers that if you have questions for Reena, feel free to post them on our Hangout here, and we'll make sure to answer them.
Great, and I've also included here my email address if there's any follow-up questions after today's session. So just a little background about myself. I went to Carnegie Mellon and studied there in electrical and computer engineering. I did my bachelor's and master's degrees there before I headed to Austin, Texas. I worked at Intel for about 8 years on microprocessor design. And while I was working at Intel, I pursued my MBA in the evenings from the University of Texas at Austin. Once I completed that, I decided to move to Google, and have been working at Google for about the past 6 years. I'm currently on the Android team, as I mentioned, working on speech recognition. So one of the big things about speech recognition is it's become more and more prevalent to users because of the importance of inputting onto smartphones. The growth of smartphones is phenomenal. If you look over the past few years, smartphones was only around 100 million devices early on, but you see that growth curve has been just huge compared to PCs, which have pretty much been flat. And with this type of growth and the introduction also of tablets, users don't want to be typing every character when they're trying to input things onto their device. And so we're trying to make it easier for users to access the internet or interact with their phone in general. And when they're doing that, one of the easiest ways is through voice. But the only way people are going to use voice to actually input a text message or ask a voice search query is if the recognition is good enough. And so our team has worked hard so that when you speak something to your phone, like what's the weather today, or how old is Barack Obama, you actually see the same words that you've spoken on the screen, rather than something that in the past may have been a lot less accurate and not useful to you. And one of the big things is this isn't just a US phenomenon. The growth in other countries has been even bigger. If you look at some countries like Egypt or India, the percentage of mobile-only users is 60 to 70%. That's huge for the number of people that are depending on the smartphone to get to the internet. And so it's even more important for us to figure out ways that not only can we understand and recognize English, but recognize other languages as well. And today our voice recognition handles more than 50 languages across the world. So you can imagine all the computer science problems with that, where we have to understand different dialects, different ages, genders of people across all of these different countries. And every language has its own idiosyncrasies. So there's going to be different idioms in those words. There's going to be different annotations on how people speak. And we have to understand all of that in order to actually have the right accuracy in every language. If you look at evolution of search as a whole, when Google started as a search engine, it was a very basic search results page that we would present, just containing blue links. So people would type in a search query, and the results that they would get would just be a series of blue links that they would click on to get to the next page. And over time, we've made that richer and richer. So now we're a lot more than just keywords. You see links, but you also see things like images, that you can scan through, and also like quick answers. So on here you'll see the status center, which has some quick information about it, like its architectural style, when it opened, so that you don't have to click through to another page. Google's mission has always been to organize the world's information, and we want to get people this information as quickly as possible. So rather than have to link through a few different pages, we try to give that information right away. And as I mentioned, people aren't only accessing through the desktop, as these images show. That's moved now to mobile and voice as well. So we've tried to bring this interface to an easier, accessible way through mobile, and that's introducing this microphone into our applications, where users can press on the microphone and ask Google search any query that it wants. So in this case, how tall is the Eiffel Tower? We've asked the device, and now it tells us the answer right away, 1,063 feet, rather than making me click through any other options. So you can see on a mobile device how important it is to be able to ask your question in an easy way and get your answer back most quickly. So these are just some more examples of how we're handling voice search and taking queries or what a person has typed into the search box and coming back with spoken answers. So not only do we recognize what the person has said, but we also speak back the answer to you. So in this case, what will the weather be like in Monterey on Saturday? The user is asked voice search. We would speak back something like, the weather in Monterey, California is going to be 12 degrees today, but we also show that on the screen. So we're trying to create a conversation with the user. We don't want people to just think of this as a one-way interaction. We want people to think of Google as a place you can go and have a conversation, get the answers that you want, and think of it as talking to a friend and not just talking to a search engine. So we want people to speak more simply, like what movies are playing this weekend. So this is going to use the user's location and determine where this person is to give you the right theaters and the right times that are relevant to you and how far they are from your house. You don't have to say what movies are playing this weekend in Mountain View, California. We figure out the location based on your smartphone. So there's a lot of things that we can do on a smartphone that used to not be possible without that type of information. And when you talk to a friend and you ask a friend what movies are playing this weekend, you want to speak just like that in a very conversational way, rather than saying something of what we used to call Googlish, which is more of how a user would type a query, like movies, Mountain View, California. That's not how you would speak to a regular person. So we're trying to make it easier for someone to just speak to the phone as they would to a friend. So if you, a little bit of basic background about speech recognition is it's actually a pretty intricate model to break it down from the audio to the actual meaning. So when we get someone speaking to your phone, like what movies are playing today, we take that audio and we break it down frame by frame to understand the acoustics of it. So every word that you stated, we break it down into the smallest possible fragments that we can then map to phonemes. So this is like simple tones like ah or e or s. And so we understand all these small tones and can pull those together to build out a word. So we use the lexicon to match all of these small character fragments into a word. And then we use a language model to determine what words might complete this sentence. So as someone is speaking, we can base what they might have said based on history of understanding language as a whole. So we have a language model that says, if you've said something like how are, the next word might likely be you because of what we understand about language as a whole. And so we have tons of data about how people speak and how people ask queries so that we can build out a language model to make those kinds of assumptions. And once we have that sentence, we actually use natural language processing to develop a meaning. And that means that you can say something to your phone like, do I need an umbrella today? And if I said, do I need an umbrella today, you're not looking for necessarily links into something about umbrellas. You're wondering what the weather is. So we take that information and actually parse it to mean this person's asking for today's weather and whether it's going to rain. And we give that information back. So the recognizer has recognized the actual words, do I need an umbrella today? But natural language processing is used to understand what that actually means to the user. So this is a really interesting problem, and there's a lot of different people that focus on all of these different aspects to go from a user's spoken audio all the way to what they really meant when they spoke it. So just looking at really what that means is, one example is the language model. So when someone says something like call Starbucks or call McDonald's, it's just a state machine where we say, well, the first word they've said is call. Now the second word is either going to be Starbucks or McDonald's. So we look at the characteristics of what the person has spoken and which word acoustically matches better. But we know that if they sound very similar, then we look at the weighting of which one is more likely. But we have billions and billions of training examples and over 100 million tokens to actually train this kind of model. And not only do we have understanding of language as sentences, but we also make it so that it actually looks like text you would have written. So we have things like automatic capitalization. So if I've stated a city and a state, I can put in there, when I show it to the user, it doesn't just say weather in Scarsdale, New York, in all lowercase. We recognize that the person has stated a city and state, and we actually capitalize those on our own. We also allow the user to speak punctuation. So if you were going to speak a text message, you wouldn't want it to just be a long string without any punctuation. So you can say things like, how are you? Question mark. I am having a great day! Exclamation point. And those will all show up as true punctuation rather than writing out the word punctuation mark. We also look at things like verbalization. If someone says 2012 or 2012, we know to not write out the number in words or alpha words. Instead, we use the numerics and showed 2012 because that's typically what the user would have written if they wrote it themselves. So we have to understand when a person is speaking, what they're really intending in terms of the written domain. And so we look at the context of what's been spoken and try to relate that back. So our model is huge. We have billions of word tokens, billions of word vocabulary. We use a lot of input from past queries to continue to build it. And if you want to better understand how the lexicon works, we basically are breaking down, as I mentioned, those small word fragments. So the word call, the pronunciation breaks down into k, all. And each of those is going to have its own weight as well. So we can figure out what the person has said based on the likelihood of each occurrence. And we do that per word based on what we've heard. And this just shows a quick view of what the acoustic side looks like. So we're looking for actual spoken tones. We map them frame by frame. We break it down into each part that we've heard and actually map that into an acoustic model that we can map to the phonemes. So not only, as I mentioned, are we recognizing the words word for word, but we're also trying to come up with a meaning. So here, if the user said, remind me to pick up milk on the way home today, we look for things like a place, which is home, a time, which is today, and a topic, which is pick up milk. And we're able to actually create a calendar entry based on this. And so we try to learn how people are speaking, and we create a model around that so that every time we see this pattern of remind as a first word, a topic, a location, and a time, we can parse that and do something useful for the user, in this case creating a calendar entry that as you're driving home, or maybe a notification as you're driving home, to ask the user to stop at the grocery store. So reminders are really important because typically people just think about it and they speak to their phone, but they don't want to jot themselves an email or do a recording to themselves. So this is a quick way for someone to just make a spoken reminder and have it processed into something more useful. And going past meaning, we're actually, as I said, trying to create a conversation with the user. So when a person is talking to a friend, you don't typically repeat the same words over and over. So if I was to say, how old is Angelina Jolie? And then I wanted to follow up, like, where was Angelina Jolie born? If I was talking to a friend, I wouldn't keep saying Angelina Jolie, I would start to say she. And so similarly, Google, if you say, how old is Angelina Jolie, where was she born, we understand that when you said she, you actually meant Angelina Jolie based on your previous query. So we're trying to learn from the flow of what you're asking so that you can be more simple when you're asking things to Google. Similarly, if I said Italian restaurants in Boston, and then my next query is how about Thai instead, this is a much more conversational interaction. But simply by saying how about Thai instead, I give results for Thai results in Boston because I know that you're looking for restaurants in Boston. And so I can use the information that you had in your previous query to help refine your current one. And going past that even further, we introduced Google Now in the middle of last year, which actually uses a lot of information from you and shows cards on your Android phone which show things like how long will it take me to get to work, what are the things happening nearby that I might be interested in, what is my flight information, and all of these things it's doing based on other information of things you've asked in the past. Like if you've looked for a maps query to a specific restaurant, it will tell you how far away you are from there or other information about that restaurant. So based on information and things you've done in the past, we can try to give you whatever information we think might be useful for you moving forward. So this is an example of other cards that we would show. So if you had an email that's showing a package is shipped, then we might show you a card showing, when it's expected to arrive or tracking information. Or if you have something that has a hotel reservation, we would show a card with that hotel, what time is check-in, what time is check-out, directions to that hotel, all the information we think you would need by just a quick swipe, rather than having to do a full Google search to go find more information about that hotel that we already know you're planning to go to. And this also shows other cases of Google Now, like flight information. You had an email that said United Air Flight 1457, so we know you're headed to this flight, and we want to tell you it's on time, what time it's planning to depart, whether it's going to be late, and other popular places that may be relevant when you arrive. So how to get there on the subway, popular photo spots. We give you all that information knowing that those might be in places of interest once you arrive. If you look here at, as I mentioned, follow-on queries, so if I say something like, how old is Barack Obama? What is his wife's name? So rather than have to type in what is Barack Obama's wife's name, I could just say what is his wife's name, and it actually shows me Michelle Obama because it understands from my previous query that that's who I was talking about. Similarly, if I said, if I spoke Italian restaurants in Mountain View, California. So you'll see that I spoke Italian restaurants in Mountain View, California. It capitalized things like Italian, Mountain View, and California, and it showed me very rich results that I can actually scan through and find reviews, information, names and locations, and the number of reviews, the dollar expectation, and as I pan over them, it actually shows them to me in the map. So there's so much rich information that we now show on the immediate page rather than just search results. And if I follow this up and say, How about Thai food? Well, it didn't get that one. But I can correct it as well. And it's only basing the queries, so since I had looked around for a while, it may not, and I did another query in between. That case did not work, but you should be able to also update your query based on your previous one. And another fun example of other ways that search can be, or sorry, speech can be used by users is you can see here where someone has used our speech APIs, which we make available to access our recognizer, to actually create a fun way to annotate a movie. So here, action. How are you? I am doing fine. What are you trying to sell me? How are you? Question mark. So in those cases, this movie isn't playing well over the Hangout, but you can see how it was actually understanding what I was speaking and annotating a silent film. And this site actually allows you to actually take your whole annotated silent film and upload it to social networks. So just a fun way of using speech to talk to your computer in this case. So we're really hoping that people can find ways to leverage speech recognition rather than typing as another input method to your devices.
If teachers have, if teachers want to put something together like this very cool project, in their CS classrooms, is there a way that they can access the API in order to do so? Is that publicly available?
Yeah, so we actually have two publicly available APIs. One is through Android and the other is through Chrome. And the Android APIs are the Android.speech APIs, which you can integrate into any Android application. So if you look at the developer SDK for Android, the Android.speech APIs describe integrating a microphone into your application and tying it to our recognizer. So there's several applications on Android that currently leverage that. And similarly, we have an HTML5 speech API for Chrome, so you can build Chrome or web-based applications that are also leveraging our speech recognizer.
Very cool.
Were there other questions?
A couple. So I'm very curious. In honor of CS Ed Week this week, how did you get your start in computer science? Because it looks like you have a rich background in CS, but what inspired you? How did you start out?
Sure. Let me just go ahead and close these slides. So I actually started off somewhere, I guess, freshman year of college, because prior to that I really wanted to be a doctor, but I passed out a few times while volunteering in a hospital. So I decided that that was a little too much and I wanted to do something else that was still very fun and creative and helping people. And so I found that computer science still gave me a chance to help people, but just in a different way. And so as a freshman in college, one of the classes focused on programming our own robot and running it through a maze. And I found that to be a really fun project, and we worked on that throughout the semester. And after that, I decided to major in electrical and computer engineering, which has a lot of aspects of computer science as well, but also gave me the opportunity to mix it with hardware. And so this, after that I went to Intel programming, models to represent the microprocessor hardware, but I was programming software models. And then when I came to Google, I've been working on Android, which is also a mix of hardware and software. So I think that it's really fun to be working on something very tangible, but working on kind of the software aspects behind it.
So what's the difference between your job as a technical program manager and an engineer?
So today as a technical program manager, I'm working cross-team a lot. So I'm working with, as I mentioned, our speech recognition engine is used by a lot of teams within Google. So it's used by Google Glass, it's used by Google Translate, it's used by Google Maps, and a lot of other teams who have integrated a microphone somewhere into their device. And that means there's a lot of questions that need to be asked to our team and a lot of coordination amongst these different teams to get something actually launched. So I work closely with these other teams and bring information and requirements back to my own speech engineering team to indicate what priorities we have. And we also look at things like what languages should be the next thing that we launch. So we've launched in 40 or 50 languages today, but obviously there's a lot more than that in the world. So we have to look at things like, what language makes sense and what language is the best place for us to focus our attention in 2014 and in 2015, and how long will it take us to get there, and how long will it take us to launch. So I have to understand all the engineering background to these issues, but I'm not currently coding, 100% of the time. Instead, I'm looking at technical problems and coming up with solutions to bring back to our team.
And you talked about this a little bit, but just to get maybe a little bit of a longer answer, why is voice search and voice recognition so important?
Yeah, so I think the biggest reason is the big growth in mobile usage. So definitely people are using in some cases, a very small device, and they're on the go, so they want to do things as fast as possible. So voice search has become incredibly important in that respect. Also, people want to be able to just ask their phone something and treat it like an assistant. So people don't want to just think of it as a search engine, but instead as something that can help you with figuring out when your next meeting is, figuring out how to get to your friend's house, figuring out how to make a restaurant reservation, all the things that if you had a personal assistant, we want your phone to be able to do. But you don't think of a personal assistant as someone you would type messages to and someone that you would pass these post-it notes to of information. Instead, it's someone you just speak to and get answers back. And so if we're truly creating an assistant, it has to be someone that can be conversational with you. And that's why voice search makes the most sense as the input method for that type of use case.
Absolutely. So for a student who sees this and thinks that this is the most amazing thing ever, what would you recommend or what would you say are the most important tools or things for them to learn to someday get to work with you or on your team?
I think it's great if they think it's the best thing ever. It's definitely something that we think actually makes students like to interact with phones too. When I've spoken to students, and I work with a lot of students on a volunteer basis, they love that you can talk to your phone and see the words come up that they're speaking. I think the biggest thing is the same as any computer science field, is just to work really hard in neuroscience, math, and computer science type classes and get as much exposure as possible. In the younger grades, there's a lot of early exposure tools to learn basics of programming, like Scratch, and Google actually recently launched a product called Blockly, Blockly, and that's all publicly available online, and you can use it in a classroom to teach drag and drop programming through puzzles and other like drawing tools that allow students, similarly to Scratch, to kind of learn the basic concepts of programming, like loops and if-else statements and things like that. So that's kind of early programming ideas, and then later things of getting exposure to actually writing code or trying basic things like App Inventor to build a mobile application. All of those things are really great exposure. But I think the big thing is to just find something you're really passionate about, because if you're working on something that you're not passionate about, you're not going to work very hard at it.
Another question is, this is from someone who is developing world university and school, like Wikipedia with MIT, OCW, with plans for schools with voice in all 7,105 languages. So that's the background. And the question is, how many languages do you anticipate Google to develop in?
We would love to develop in all those thousands of languages that exist, but it's just a matter of time. We actually, every time we launch a language, it's quite a big effort. We actually take phones to users in that location and have them record phrases. So, we recently launched Croatian, and we go to Croatia, we take a bunch of Android devices, we give them prompts like speak all of these phrases, and from that's our original data set to actually build out the model. And so there's a lot of time involved with actually doing the initial data collection, and then we work with linguists to actually break that down and understand the patterns of that language, to build out the lexicons and on all the other speech-related things that we'll need. And then there's engineering effort actually using all of that data that has been pulled together. So, I mean, obviously we would like to have every language out there, but there's some languages that are a lot more easily done by us than others. Not only are the pieces that I already mentioned, but we also have to have this language model of understanding of sentences and how words are put together. And a lot of that we can learn from the web. So if you just look at the web, there's so much content on there. But there's only that kind of content for certain languages. There's a lot of languages that really have no presence for written content like that. So learning those long-tail languages that don't have that kind of content is a really big challenge. So, while we're working on a lot of languages, it's just a matter of time for how we can really get all of them out there.
So this person asks, can I ask, quote, where is, my friend's name, question mark, or is my friend's name online on G+, Facebook, etc.? So can you search by somebody in your address book or somebody that you know?
So we definitely have some what we call voice actions related to contacts. So you can say something like call Aaron or email Aaron or text Aaron. So I can do those three actions with a contact's name, but there are kind of specific things today with contacts and others that we don't yet support. So the ones you specifically mentioned, like is Aaron online on G+, it's not an action we support today, but obviously we want people to speak very naturally and ask those types of questions, but we have a long way to go. I mean, there's so much that we want this assistant to be able to do. You can do things today like post to G+, or post to Facebook, so you can just speak something like that, because we're trying to do it based on usage, right? So trying to take the most common things that people are doing and make those easier. And so people are very frequently saying things like, call Bob, or email Joanne, how are you, right? So things that people are doing most commonly is where we would start, and then keep expanding that as we go.
So does your team use interns, or do you have internships available?
We definitely have a lot of interns. Several of the interns in our team are PhD students, so speech recognition as a whole often has a lot of researchers, and so a lot of our team is PhD level. But we have had undergrad interns and master's students as well. I would just say the majority of interns, specifically in the speech team, have been PhD students. But across Google as a whole, there's thousands of interns, and across all of our sites for Google. And that covers undergrad all the way through grad school. And we also have programs even geared for high school students that may not be full internships, but are partial exposures to computer science.
And those can be found at google.com/jobs for anybody who's interested in checking those out. Reena, thank you so much. This has been very informative and interesting. if you have any final words you want to give, I want to give you that chance, but I wanted to thank you. And I learned a lot from this, and I think it's really exciting what you're working on and what's coming down the pike. So thank you.
Great, I really had enjoyed it, and as I mentioned, my email address is reena@google.com. I'd be happy to answer any follow-up questions, and thanks a lot.
Thank you.
Thanks, bye.
Bye.